Now in this video, we're going to talk about triangles. Triangles are really fundamental to trigonometry. The word trigonometry actually comes from two Greek words for triangle and measure. So when you're learning trigonometry in high school, you usually start out with right triangle trigonometry. In this class, we're going to expand that a little bit to talk about some other ways to treat trigonometry. Now, the first thing we need to know when we're looking at triangles is how to classify a triangle. So it turns out that there are two different ways to classify a triangle, depending on whether you want to look at how the sides compare to each other or how the angles compare to each other. Okay, so if we're classifying a triangle using lengths of sides, there are three different classifications. The first is the equilateral triangle. Okay, and that is a triangle that has all three sides the same length. Now, if a triangle is equilateral, it also means that all three of the angles have to be the same measure. You may recall that the angles in a triangle have to add up to 180 degrees. That means that every angle in an equilateral triangle has to be 60 degrees. Okay, the next classification is the isosceles triangle. So an isosceles triangle has exactly two sides the same length. And finally, the scalene triangle has no sides the same length. All three sides have different lengths. Okay, now for the most part, we're going to be concerned about classifying triangles in terms of angles because we're mostly going to be working with angles in this class. As we move on to the last unit and we start talking about some things related to sides of triangles and areas of triangles, this will come back, but for right now, we're going to be looking mostly at angles. So when we look at triangles classified by angle measure, there are, just like when we classify using sides, three different classifications for triangles using angles. The first is the acute triangles. An acute triangle is a triangle that has all three angles acute. And recall, an acute angle is one that is less than 90 degrees. Okay, so an angle that is between 0 and 90 degrees. An acute triangle will have three angles that are all less than 90 degrees. Okay. We also have the idea of the obtuse triangle. An obtuse triangle is a triangle that has one obtuse angle. So recall, an obtuse angle is an angle that is greater than 90 degrees and less than 180 degrees. Note that for an obtuse triangle, we can have at most one obtuse angle because the other two angles have to add up to something less than 90 degrees so that the three angles add up to 180 degrees. And finally, and most relevant to what we're doing, we have the idea of the right triangle. So a right triangle is a triangle that has exactly one right angle. Let's recall, a right angle is one that is equal to 90 degrees, or pi over 2 radians. The other two angles necessarily have to be acute because, again, the three angles have to add up to 180 degrees. That means the other two angles have to add up to 90 degrees, so they have to be less than 90 degrees. Now we have one further classification. Sometimes if we have a triangle that is not a right triangle, we will refer to it as an oblique triangle. And again, once we get into the last unit and we look at the law of sines and the law of cosines, we'll be doing a lot of things with oblique triangles. Right now, we're going to be focusing on right triangles. Okay, so those are our classifications for triangles. Now, when we work with right triangles, there are going to be two main tools that we're going to be using moving forward. The first is a geometric identity called the Pythagorean theorem. The Pythagorean theorem is really just an equation that relates the lengths of the three sides of a right triangle. So we have a right triangle. So again, this is going to be a triangle with a right angle, a 90-degree angle in it. This triangle, of course, has three sides. And the two sides that form the right angle are generally called the legs of the right triangle. And then the third side, the one that connects the two legs, is called the hypotenuse. So the Pythagorean theorem states that if A and B are the lengths of the legs, and C is the length of the hypotenuse, then A squared plus B squared equals C squared. Okay. And when we're working with triangles, the lengths of these sides, they're a length, so they're going to be positive numbers. So you want to keep in mind when you're solving this equation, you're going to have to take square roots, and when you're taking square roots, there's always the question of, are you taking the positive or the negative square root? Well, in this case, again, A, B, and C in this right triangle are all going to be positive numbers because these are lengths. When we get into trig functions in the xy plane, that is not going to be the case always. So in this case, we can always take positive square roots. When we move on to material from a future unit, then we're not going to be able to lean on this fact. Okay, so let's go ahead and do an example. All right, so let's suppose we have a right triangle. Whose hypotenuse has length 3. So we'll call that C. Let's suppose one of the legs has length 2, and we're trying to find the length of the other leg. So using the Pythagorean theorem, it's going to be the case that 2 squared plus B squared is 3 squared. A squared plus B squared is C squared. So 4 plus B squared is 9. We want to solve for B, so we'll move everything else to the right-hand side. Subtracting 4 from both sides, we get that B squared is equal to 5. And then we can solve by taking the square root. And again, B is going to be a length. It's always going to be positive. Therefore, it's going to be the positive square root of 5.